it's me again, Angie, and welcome to another video. For today's video, I'm going to discuss you the summary of Chapter 4 in Cisco. Chapter 4, Network Access. For the introduction, this chapter began with a look at the TCP or IP protocol suite. This included a look at the protocols that make up TCP or IP and the way in which they relate to the ISO or OSI model. A look at network layer protocols provided an overview of IP packets and addressing the way in which ARP is used to map IP addresses to MAC addresses, as well as how ICMP provides error reporting and diagnostic information. Examination of protocols at the transport layer provided an overview of both TCP and UDP, including their header structures. A closer look at TCP provided insight into port numbers, how connections are defined, how they are terminated. An introduction to UDP provided perspective on how it differs from TCP as a connectionless protocol with lower overhead. So for the objectives of this chapter, physical layer protocols, to identify device connectivity options, describe the purpose and functions of the physical layer in the network, describe basic principles of the physical layer standards. For network media, identify the basic characteristics of copper cabling, build a UTP cable used in Ethernet networks. Scope does not include cabling area discussion. Describe fiber optic cabling and its main advantages over other media. Connect devices using wired and wireless media. For data link layer protocols, describe the purpose and function of the data link layer in preparing communication for transmission on the specific media. For media access control, compare the functions of logical topologies and physical topologies. Describe the basic characteristics of media access control method on LAN topologies. Describe the basic characteristics of media access control methods on LAN topologies, and describe the characteristics and functions of the data link frame. Explain how physical layer protocols and services support communications across data networks. Build a simple network using the appropriate. Explain the role of the data link layer in supporting communications across data networks, and to compare media access control techniques and logical topologies used in networks. Controlling access to the media. Media access control is the equivalent of traffic rules that regulate the entrance of motor vehicles onto a roadway. The absence of any media access control would be the equivalent of vehicles ignoring all other traffic and entering the road without regard to the other vehicles. However, not all roads and entrances are the same. Traffic can enter the road by merging, by waiting for its turn at a stop sign, or by obeying signal lights. A driver follows a different set of rules for each type of entrance. In the same way, There are different methods to regulate placing frames onto the media. The protocols at the data link layer define the rules for access to different media. These media access control techniques define if and how the nodes share the data. The actual media access control method used depends on topology and media sharing. Topology refers to how the connection between the nodes appears to the data link layer, while media sharing refers to how the nodes share the media. The media sharing can be point-to-point, such as in WAN connections, or shared, such as in LAN networks. Physical and logical topologies. Physical topology refers to the physical connections and identifies how devices and infrastructure devices such as routers, switches, and wireless access points are interconnected. Physical topologies are usually point-to-point or star, while logical topology refers to the way a network transfers frames from one node to the next. This arrangement consists of virtual connections between the nodes of a network. These logical signal paths are defined by data link layer protocols. The logical topology of point-to-point links is relatively simple, while shared media offers different access control methods. For common physical WAN topologies, WANs are commonly interconnected using these physical topologies: the point-to-point, hub and spoke, and mesh. Point-to-point refers to the simplest topology that consists of a permanent link between two endpoints. For this reason, this is the very popular WAN topology. Hub and spoke, a WAN version of the star topology in which a central site interconnects branch sites using point-to-point links. While mesh, this topology provides high availability but requires that every end system be interconnected to every other system. Therefore, the administrative and physical cost can be significant. Each link is essentially a point-to-point link to the other node. Physical point-to-point topology. In this arrangement, two nodes do not have to share the media with other hosts. Additionally, a node does not have to make any determination about whether an incoming frame is destined for it or another node. Therefore, the logical data link protocols can be very simple, as all frames on the media can only travel to or from the two nodes. The frames are placed on the media by the node at one end and taken from the media by the node at the other end of the point-to-point circuit. For logical point-to-point topology, the media access method used by the data link protocol is determined by the logical point-to-point topology, not the physical topology. This means that the logical point-to-point connection between two nodes may not necessarily be between two physical nodes at each end of a single physical link. Physical LAN topologies. This includes star, extended star, bus, and a ring. Star. End devices are connected to a central intermediate device. Early star topologies interconnected end devices using Ethernet hubs. However, star topologies now use Ethernet switches. The star topology is easy to install, very scalable, easy to add and remove end devices, and easy to troubleshoot. Extended star. In an extended star topology, additional Ethernet switches interconnect another star topologies. An extended star is an example of a hybrid topology. Bus. All end systems are chained to each other and terminated in some form of each end. Infrastructure devices such as switches are not required to interconnect the end devices. Bus topologies using coax cables were used in legacy Ethernet networks because it was inexpensive and easy to set up. Ring end systems are connected to their respective neighbor, forming a ring. Unlike the bus topology, the ring does not need to be terminated. Ring topologies were used in legacy fiber distributed data interface or the FDDI and token ring networks. Half and full duplex. Half duplex communication. Both devices can transmit and receive on the media but cannot do so simultaneously. The half-duplex mode is used in legacy bus topologies and with Ethernet hubs. WLANs also operate in half-duplex. Half-duplex allows only one device to send or receive at a time on the shared medium and is used with contention-based access methods. While full duplex communication, both devices can transmit and receive on the media at the same time. The data link layer assumes that the media is available for transmission for both nodes at any time. Ethernet switches operate in full duplex mode by default, but can operate in half duplex if connecting to a device such as an Ethernet hub. Lastly, media access control methods are contention-based access and controlled access. Some multi-access networks requires rules to govern how devices share the physical media. So these two basic access control methods are for shared media. Contention-based access. All nodes operating in half-duplex compete for the use of the medium, but only one device can send at a time. However, there is a process if more than one device transmits at the same time. Ethernet LANs using hubs and WLANs are examples of this type of access control. So for controlled access, each node has its own time to use the medium. These deterministic types of networks are inefficient because a device must wait its turn to access the medium. Legacy token ring LANs are an example of this type of access. So by default, Ethernet switches operate in full duplex mode. This allows the switch and the full duplex connected device to send and receive simultaneously. So that's all. Thank you. Thank you for watching and see you on my next video. Bye!